So forces and resultants, we're gonna just cover this till here. Gonna end the class because I have another class in 3 minutes. So yeah. So let's see what is being shown over here, right? We have discussed this in the last slide. It's just a summary of that. They are simply stating over here, which we have seen, force has a magnitude and a direction, right? That is why it is a vector quantity, which we have seen in the last slide, right? So it is represented by a free in the free body diagrams by a straight line with an arrow to show its direction of action, which we have seen. Okay, we show a force by this, right? It has a direction. It has basically in this, it has a magnitude. Let me just fix my spelling. It has a magnitude plus a unit in this value. Okay, and this is the direction. That is why it is shown by a vector, right? And it is a vector quantity, right? So this is an interesting statement over here. Usually more than one force acts on an object, right? Imagine you're sitting on a chair or a sofa or a bed, okay, and anywhere you're sitting, right? So imagine a ball on a table over here. It is basically not moving. It is stationary, right? So you assume that this is the center of this particular object, right? For simplicity, we basically assume okay, we take the center of mass, right? We have discussed in the last chapter what is center of mass, right? So what is center of mass, Hamza? What is center of mass? Is Hamza here? Yes. Hamza, what is center of mass? So anyone else who wants to participate and explain center of mass? I want you guys to answer this question. So it's basically the point at which all of the mass is basically appearing to act, right? It is a point at which all of the mass is concentrated, right? All of the mass of an object is concentrated, right? So we assume for simplicity in physics, okay, this is the point where we can just show, okay, this is the object center of mass, where the entire mass is acting of an object, right? So ek to vector is the weight, which makes sense because of gravity. And due to contact, we have another force that is basically acting upwards, that is called R, right? So if you want to find the resultant force, that is going to be a vector sum, right? Let's take this as positive, right? This direction is positive. So it's going to be W minus R. Since they both are same, so resultant force is 0, right? And that is why it is stationary, right? This bowl of fruit is stationary over here. It's not moving anywhere else, right? We will discuss okay, what does resultant force 0 means over here with this example, right? Imagine you have blocks, block A, block B, block C, block. Let me just give it a single name. This is block A and this is block B, right? So we have two cases over here. We have F1 in this direction and we have we have F2 in this direction, right? So imagine if you just recall again your basic mathematics classes. And if you recall, okay, this was positive X, this is positive Y, this is negative X, this is negative Y, right? We're going to only concentrate on X axis right now, okay? So we can remove Y axis till now. So we have this, let's say this is the center point O. On the right, we have positive direction. On the left, we have negative direction, right? I'm going to take this direction as positive, right? So if I want to find the resultant force in this case, that is going to be what? The positive force F1 and basically negative minus the negative force. So, oh, sorry. So you can see that F1 is also in this positive direction and F2 is also in the positive direction, right? So you just vector add them, right? It's simply addition of forces, right? So अगर दोनों same direction में है, you're gonna simply add them together. So it's going to be 1 plus 2. Therefore, the resultant force, the final force which is going to basically be pulling or pushing the object is going to be 3 newtons in this direction, right? Similarly, let's see the scenario B. You have what? You have this basically is a positive direction and this is basically in negative direction, right? So you can just simply add them up, like basically basic arithmetic, right? So it's going to be positive 3 plus negative 2, right? And this is going to be 3 minus 2. And the resultant force acting on this block is 1 Newton, right? In this direction. Why is in this direction? Because you got the answer to be overall positive, and positive states K, your motion it will be in this direction, right? This direction. So is this vector addition of forces clear? If it is clear, quickly give me a thumbs up. I'm going to give you a question right now to solve.
So could you
Okay,
explain
clear.
it again?
Yes,
Can
Mir.
you please?
Yes, Azam. Clear?
Could you explain it again?
Yes.
Okay.
Can you please
Yes,
explain
Mir.
again?
You had a question?
Yeah, could you explain it again? I didn't get this.
Which part? Block A, block B.
Yeah, um, block A part.
Block B. Block A.
A,
A, okay,
yes.
we can. Let me just make it on another slide. You have a block over here, right? And you have one force in this direction, right? That is 2 newtons. You have one force in this direction, right? 1 newton. Imagine this is force 1. Imagine this is force 2, right? So as I said, K, if you, this is the center point of your x-axis, so this is positive x direction, right? And this is negative x direction. So if any motion is in this direction, we consider them as a positive value, right? So you can see if you want to find a resultant force, that is simply a vector addition. It's basically simply mathematical addition, right? So your F1 is in this direction, that is positive, so you will have plus F1. Similarly, if you see this F2, it's also in this direction, that is also positive. It's going to be plus F2, right? Just now put in the values to get your overall resultant force. The what is the resultant force? That is the final cumulative force that is actually causing a motion of block A in either left direction or right direction, right? So we have 2 plus 1, get positive 3 Newton, right? So the final scenario will be as follows, that this block will be moving to the right with a force of 3 newtons. Why to the right? Because this sign is positive. It states K motion will be in this direction, and the magnitude of the force would be basically 3 newtons, right? Does that make sense?
Yeah, got it.
Okay. Now let me give you a question
Yes.
just to basically finalize this concept, and then we're gonna call off the class, or I'm getting text from the students. Is a class starting already? Okay. Let me just text them. Okay. So yeah. So okay. Test yourself. So you have this block A, and these are the forces acting on this block. F1, F2. Given F1 equals to 1 Newton, F2 equals to 4 Newton, F3 equals to 0.5 Newton, and F4 equals to 1 Newton. What is the resultant force acting on block? It's of 2 marks. Okay, quickly speed up. So you have this particular scenario, and just want to find the resultant force, right? And how do you find the resultant force? As follows. Just resultant force is just basically vector addition, right? You see first of all F1, right? And this direction is positive, right? This direction is negative. So you see F1 is in the direction of positive, so it's positive F1, right? And F2 is the direction which is basically this. So therefore, we'll put a negative sign with F2. Similarly, F3 is also positive and F4 is also positive, right? Because they are both in the positive direction. Now you can just simply, therefore, put in the values of the forces and get your answer. F1 was 14.51, right? So it's plus 1, negative negative 4, a negative 4 plus 0.5 plus 1, right? And what does it give you? 2 minus 4 negative 2, it's give you basically negative 1.5, right? What does a negative sign represents? That your final block motion will be as follows. It will basically be moving towards the left with a resultant force of 1.5 newtons. If your answer is matching, give me a thumbs up. Okay, it matches for Ryan, matches for Hamza, Mashal, Varda. Okay.
सर
Yes,
सर हम लोग उसको ऐसे लिख
Hamza,
सकते हैं 1.5 न्यूटन टुवर्ड्स द वेस्ट
can you speak loudly?
हम लोग ऐसे लिख सकते हैं 1.5 न्यूटन टुवर्ड्स वेस्ट
Not audible. Yes. बोला बस.
हम इसको ऐसे लिख सकते हैं कि 1.5 न्यूटन टुवर्ड्स वेस्ट
Yeah, towards north, south, east, west. Yeah, towards west. Yeah. Hamza is saying कि if you recall your map, this is north, this is south, this is east, this is west. So yeah, you can also write it down कि this is as follows. Resultant force is 1.5 newtons towards west.